According to the general theory of relativity, if space were to stretch in the expansionary phase of the universe, time should contract in a complementary way. The increase in potential energy would be limited by the contraction of time, without the need for it to reach maximum values only at infinity. It's just that, without measurable time, there is no movement. The opposite should occur, but in a recordable way, within space-time. Here, space always seems to be contracting, accompanied by the continuous dilation of time towards our event horizon. The constant presence of gravity, the only known force acting on the astronomical scale, and the continuous drop in potential energy, seem to define what would be the second phase of the harmonic movement of light, the same light that science uses in remote tracking of distant events. The continuous action of gravity would exclude the presence of any other force that has a contrary orientation, as would be the case with antigravity and centrifugal force. Thus, there could be no expansionary phase of the space spring acting in real time, as it would necessarily be followed by an increase in potential energy. This would result in continued deceleration of the galaxy's motion. Astronomers assume that the light of the stars is coming from our past, not our future. There is a logical explanation for this, which would be supported by the contraction of time in the expansionary phase, and, by the way, before the Big Bang event. Without time, so placed relatively in the future, in relation to our present moment, there would be no movement, and events could not be remembered. You remember the expansion only after the reversal in the direction of the arrow of time, when it would have come to constantly point to your past. That is, inflation would be assessed indirectly by tracking the cosmic background radiation appearing, for us, outside its own time. There is no doubt about that. Without time, the waves emitted at the singularity could not move away from the source, as the future light come from the Big Bang event would lose its depth. There would be no waves that could be tracked at the current time. This would have been avoided by the time inversion that would have occurred at the moment of the Big Bang, followed by a time dilation. Thus, we would be seeing the late manifestation of the stretching of the space spring, thanks to its own contraction phase. In this process, there would be exclusion between the phases of the harmonic motion of cosmic radiation. The contraction of time throughout the expansionary phase would shift as ground zero, removing it from the position of the singularity and placing it in our position in the present. Before we have a notion of time, the universe would be static and would compose what can be called dark matter. The displacement of this ground zero is what allows the instantaneous remote tracking of the radiation, without taking into account the time it would have spent in its previous displacement. It would also explain why we cannot remember what would happen in our future. Here comes the role of the conscious observer, endowed with a temporal memory. The expansion event and the Big Bang itself, by contracting time to subliminal levels, would place themselves relatively in our future. It is that our memory could not act in the absence of measurable time. In fact, the concept of the future would result from this virtual displacement of the zero ground of time. That is, as we always evaluate events outside their real time, the future would result from the paradox of always looking at the present with delay. Or, in other words, as if we ourselves were in the past. For the Big Bang to be remembered, it would have been necessary for it to have been accompanied by a reversal in the direction of the arrow of time. This reversal, which would have coincided with the beginning of time, would have placed the expansion outside of space-time. The Big Bang, in turn, would place itself in our position in the present, transforming itself into a Big Bang of information. The first phase of the harmonic motion of radiation predicts an increase in potential energy, then transfer it to space, in the form of expansionary motion. This negative work of the space spring would coincide with the interpretation of some physicists, according to which the Big Bang resulted from the gravitational collapse of a very massive body, forming a black hole. Inside a black hole, time does not exist, because it cannot be measured directly. The confusion between the behavior of light and that of space itself would have resulted in the formation of a spatio-temporal continuum, leaving the present moment of events outside. That is, what happened at this moment in a distant galaxy would be communicated to the observer by light, always with immense delay. Space would be left out, acting as a backdrop. The cited continuum, as can be seen, would have nothing of a continuum. Imagine that at each isolated moment, there was a transition from the first to the second phase of harmonic motion, and vice versa. This transition could not be remembered by us, due to the contraction of time, in the first phase. With the exclusion between the both, the second phase of harmonic movement, accompanied by time dilation, would become continuous. Thus, space-time would be the result of the transient condensation of energy, then secretly passed on to space. In a moment, a galaxy will be there. In the other, no. You might find this absurd, for things don't cease to exist one moment, to reappear at another. It so happens that, in the process, we are including the point of view of the isolated observer and the performance of his temporal memory. The universe does not depend on what we think about it, but it is our observation that would give meaning to physical reality.